Hi, this is Mike Adams, the Health Ranger, the Lab Director of the Natural News Forensic Food Lab, with a tour of the ICP MS instrumentation that we use to check foods and beverages and even fertilizers for toxic heavy metals or other toxic elements. And this instrument right here behind me is what I'm going to show you. I'm going to actually give you a peek under the hood. I probably should have done this a year ago. Everybody kept asking me to do it. I just got too busy using it and never really explained how it all worked. So I'm going to give you that today. I find this truly fascinating. Yes, it did take me a long time to learn this, to get up to speed. I had to hire trainers to come in and teach me, chemists who know this stuff. And I had to learn a lot in order to do this. But I find it fascinating, and we use this tool every single day to test the products that we manufacture at the Natural News store, to test the raw materials, to either accept them or reject them, and even to test the final products after we make them, to make sure yet again that they're very, very clean before we offer them for sale to the public. So this is the instrument that actually keeps your food safe. And we are one of the very few companies that does this, that has its own in-house lab. And I believe we're the only independent journalist organization in the world that actually has this laboratory, privately owned and privately run lab. And it's not cheap either, so thank you for your financial support that has allowed us to invest in this kind of technology. This right here is about $250,000 by itself. And that doesn't even count the training time and all the add-ons and all these other things. So you're probably just in this shot, you're looking at over $300,000 worth of equipment just behind me. Anyway, I'm going to give you the tour, so I'm going to grab the camera and show you the insides of this instrument and sort of explain how it works. It's pretty cool. All right, so this is the Agilent 7700X ICP MS system, and I like to put notes on the front. I give myself reminders like these are the top causes of failed calibration, just what I've learned from experience, like a clogged probe, a clogged nebulizer, dirty cones. Better not have dirty cones. I think they have a vaccine for that. And clogged Niagara valve. And these are my own notes about the Niagara Plus connections. This is a sample introduction system showing you the bubbler, the probe intake, waste pump line, and that is actually this piece of hardware right here. This is the Niagara Plus, and that valve is what's depicted in that diagram. Now I'm going to show you under the hood here too. This is pretty cool. This is the plasma torch section. Right over here is the nebulizer that atomizes the incoming liquid sample, shoots it through this tube, it's called the transfer tube, into the plasma generator, which is powered by really an RF generator, and as argon gas is shot down this tube. Let me press this button here and get it to move for you so I can show you the sample cones. Once that moves out of the way, we can unscrew the sample cone retainer and we can actually get to the sample cone itself, which is right here. Get it in the light. This is the sample cone. This has a very small hole in the center, and this is what the sample, the plasma of the sample is shot onto the tip of this cone, and a very small stream then goes through it and goes into the mass analyzer, which is inside here. Under the hood, except this isn't your 1969 Chevy. This is right here. This is all a vacuum chamber underneath here. So there's a vacuum pump that drives that. The vacuum pump is located under the instrument. This is a mass to charge ratio analyzer. The detector is over on this end, and the octopole system, which is really a stepping electromagnetic instrument device, is located right here, actually much of the length inside, and there are some extra cones in here in addition to the sample cone, which goes, well, there it is right there. Now over here we have, this is the peristaltic pump, which is called the peri pump for short. This is the auto sampler, and this is what picks up the samples. This is the probe right here. This probe goes up and down, picks up the sample, shoots it through this tube, comes into here, through this, and through this inline filter. And this inline filter takes out any of the large particulate matter that might be clogging things up. And then it goes into the rotary valve of the Niagara Plus, goes into this sample loop right here, which is a 0.5 mil loop. And after that, it gets injected into the nebulizer, which is on the back side of this. And from the nebulizer, again, it goes to the transfer tube, the plasma, into the sample cone, into the mass to charge ratio analyzer, and the detector. And then it ends up over on the software, which tells you how many parts per billion you have of lead or cadmium or arsenic or whatever you want to look for. And there's some interesting tools in all this. For example, this tool right here, this is the tool that you use to remove one of these cones. You actually plug it in like this. This is some of the maintenance that I get to do on a regular basis. And look at that, the cone is now stuck right in there as it should be, and that's how you can remove that cone and clean it. So there is you know, a fair amount of maintenance that you have to do on this. Sometimes I have to change the plumbing. Sometimes, well, frequently you have to change the peristaltic pump tube sections. Sometimes I have to, well, you clean the sample cone quite regularly because you don't want that to build up, that's for sure. If that gets dirty, your samples are basically going to be totally off. So anyway, this is the instrument. Agilent is the manufacturer, and the Agilent team really does a great job. The Agilent trainers and the Agilent hardware technicians, they're awesome. This instrument is just mind-blowingly accurate, and it's got a lot of hardware in it. It's got a lot of electronics. The software works great. It's just pretty amazing. So that's a look under the hood of the ICP MS that we use here at the Natural News Forensic Food Lab. Pretty cool.